In this video, I want to talk about exponents. We played with exponents a little bit in the previous lessons, but I really want to get into the different rules of exponents and how we can manipulate exponents to simplify our problems. So this is really going to be all about exponents for this lesson. So first, I want to review of what an exponent is. If we have some number a, this is any real number, to the n, we're going to focus on integers where n is an integer. Maybe I'll even write that n is in the integers, just as a reminder. This doesn't have to be true, but I want to focus on that so we're more simplified. N could technically be any real number, but let's focus on an integer. Anyway, let's look at a couple examples just for a refresher of what a exponent would look like. So if you have something like 2 to the 2, that's 2 times 2, which is 4, or 2 to the third is 2 times 2 times 2, and I wrote 3 for some reason, but 2. This number here, the exponent, tells me how many times the base will be multiplied by itself, and that's 8, okay? Now, you can do that with fractions, you can do that with decimals, you can do that with square roots. You can do it for any number, but let's focus on the easy stuff first, and then we'll go into the harder stuff later to kind of build those skills up. So the first thing I want to talk about beyond that is the product rule. Okay, so I'm going to write down what the product rule is. If you look in a math textbook, it might look something like this. A to the n times a to the m is the same thing as a to the n plus m. So if something is of the same base and you're multiplying them, it is argued that you can add the exponents. You can add the exponents. Let's look at an example and see if we agree that that is a true statement. If I have 2 squared times 2 cubed, is that the same thing as 2 to the 5th? Well, to verify this, I'm either going to need to already know what 2 to the 5th is, or I'm going to need to break these down and see if this is true. So let's do that real quickly and just see that we agree with this. Maybe I'll put a little question mark over that. So 2 to the 2 squared is 4, and 2 to the third is 8 by the previous slide, and so that is 32. So I'm claiming that this side is 32. Is it true that 2 to the 5th is that 32? Well, as a matter of fact, it is. We've just shown that it is. You can also go 2, 4, 8, and 16, 32. Okay, and you can see that 1, 2, 3, 4, 5. Yeah, it is. Okay, so it turns out that this is going to work. That this product rule does, in fact, tell us the truth, and we can use this. Let's look at another example. Let's say we have letters. So you have x squared times x to the 5th. Well, I don't know what x is representing. It's representing some real number, but I claim that you can add the exponents. So this would be the same thing as x to the 7th, which is 2 plus 5. Okay, so that's what the product rule is telling us. There's a good chance that many of you have already used something like that before in a previous class, but if not, that's it. Quotient rule, this is how we can divide using exponents. So if I have something like a to the m over a to the n, this one I claim that we can subtract, okay? We can subtract the exponents. So let's look at another example and see if we agree with these results. So if I have something like 2 to the third over 2 squared, well, this rule claims that you can just go 3 minus 2, which is 1, and 2 to the 1 is just 2, okay? So by the exponent rule, we're finding that the answer is just equal to 2, okay? But let's use another technique, maybe an older technique, and see if we agree with this. So 2 to the third is 8, right? So that would be 8 on top, and 2 squared is 4, and 8 divided by 4 is 2. So this is checking out, okay? So that is how the quotient rule works with simple numbers. Let's look at how it would work with letters. So you can say, let's do x to the 7th over x squared. I claim that you can say x to the 7 minus 2, which is 5. Okay, so I can subtract those exponents. So if they're being divided, you subtract. If they're being multiplied, you add. Okay. The power rule. Now, this is where students often get in trouble. So let's go through it kind of slowly. If I have a to the m, so it's already to an exponent, and then that is to an exponent itself, I claim that we can multiply these. And this is the power rule right here. So let's look at an example and see if we agree that this is true. Again, I want to do a simple example so we can fully understand the power rule. If I have something, I like picking on 2's, of course. So let's say I have 2 to the 3rd, and then, I don't know, let's square that. Let's see what happens. So, by the power rule, this would be 2 to the 3 times 2, which is 6, okay? So this is 2 to the 6. Well, we already did 32 before with 2 to the 5th, so it looks like this is going to be 64. Okay, but let's try to do it the older way and see if we agree with this. So if I simplified that, this again, just to clarify, I'm just testing to make sure I understand the power rule. So this would be an 8, and I still have the square, and so 8 squared is 64. So yes, this is working out, okay? That's the power rule, okay? But this is the one that students begin to lose their understanding of this power rule. So please go over this again and let me know. Now, the zero exponent rule. I didn't mention it in the quotient rule, but this is where this is going to come up, and I'll show you exactly where it comes up. So for the zero exponent rule, again, I'll remind you what the quotient rule is. Let's say we have 2 to the 3rd over 2 to the 3rd. And by the quotient rule I just explained, well, that would be 2 to the 3rd minus 3, which would be 2 to the 0th. Okay, well, what on earth does it mean to have a 0 as an exponent? Okay, it turns out you already know the answer to this. We just have to explain it. So what's 2 to the 3rd? Well, 2 to the 3rd is 8. And so this is 8 over 8. And what's 8 divided by 8? That's 1. Okay, so for these to be consistent, this would have to be 1. Okay, and so by definition, anything to the 0th power is equal to 1. Okay, so that's the 0th exponent rule. More often than not, what will happen is, through manipulation of our exponents, we will get a 0, and this reduces to 1. And it's really helpful because 1 is super simple. So this can also be really beneficial. Another example here would be, say I have something like x to the 27th, but I take that to the 0th. I'm using the power rule now. Anything times 0 is 0, and so this would just equal 1. Okay, so it can be, something really messy, but if it's to the 0th, it just equals 1. Okay, moving on. The negative exponent rule. Okay, this absolutely is the most confused rule of them all. So let's take a look at it. Maybe we should look at the rule first, and then we will decide how we can understand this. So the negative exponent rule says that if you have a to a negative n, that this is 1 over a to the n. Okay, well, what does that mean? You just flip it. Okay, you just flip the fraction, and then that will do it. Or said another way, you can take the reciprocal of it. This can also be written another way. If you have 1 over a to the negative n, this is a to the n. So you can flip it again. This is the one that usually gets lost in students' minds and students' notes. This one is kind of left behind, so we don't want to lose that one. Let's look at some examples to make sure that we understand what we're talking about. Let's do 6 to the 9th over 6 to the 12th and see what we get. So by the quotient rule, I would have 6 to the 9 minus 12. And 9 minus 12 is 3. So now I have 6 to the negative third because I have 9 minus a larger number, which is 12. And by the negative exponent rule, this is going to be 1 over 6 to the third. Okay, well then I can use a calculator or I can use mental math to determine what 6 to the third is. I'm going to break it up. 6 squared is 36, and then times one more 6. So that'd be 180 plus 36. So that's 1 over 216 is the final answer. Okay. So I hope negative exponents are making some sense to you.